In this video, we'll review cyclic quadrilaterals. A cyclic quadrilateral is any quadrilateral which is inscribed within a circle, looking like this. This quadrilateral is inscribed in a circle. That means all of the vertices are on the circle. Each of those four vertices of that quadrilateral is in fact an inscribed angle. Now, some types of quadrilaterals can always be inscribed within a circle, meaning some type of quadrilaterals are always cyclic quadrilaterals. For instance, the squares and rectangles. Every square and every rectangle can be inscribed in a circle. To do that, you find the perpendicular bisectors of those sides. Where they intersect will be the center of the circle. Some quadrilaterals can only sometimes be inscribed within a circle. For instance, parallelograms and trapezoids, only some of those are actually cyclic. If the perpendicular bisectors all intersect at the same point, then it'll work. If the perpendicular bisectors do not intersect at the same point, then it won't be cyclic. Now, the way we're going to use cyclic quadrilaterals is that opposite angles of a cyclic quadrilateral are supplementary. So in our quadrilateral again, we're going to look at how this works out. And I'm going to do this very informally. If we take one of those inscribed angles, and I'm going to go ahead and mark it using blue. So for instance, this inscribed angle here, and I'm going to mark the arc that inscribed angle intercepts. That would be this arc here. So that inscribed angle uses that part of the circle as its intercepted arc. Now the inscribed angle that is opposite from that, and I'm going to mark that one in green, would be this inscribed angle. And that intercepted arc for that inscribed angle would be that part of the circle. Now if we notice, the blue inscribed angle uses the blue arc, and the green inscribed angle makes the green arc, and together those two arcs form the whole circle. Now I know from before a circle is 360, or is 360 degrees. And I also know that from inscribed angle theorem, an inscribed angle is half the arc. So if those two inscribed angles together make a circle, which is 360, and I also know that an inscribed angle is half of the arc, so together they have to be half of 360, meaning those two inscribed angles together, their sum is 180. Therefore, those two inscribed angles are supplementary. Now this will also work for the other two pair. If I use the other two pair of opposite angles, I'll get that they also form the whole circle, and again, half of 360 is 180, so their sum must also be 180. So we can use this as a justification. Opposite angles of a cyclic quadrilateral are supplementary. Now let's take a look at a couple examples of how to use this. In these problems, we have cyclic quadrilaterals, or we have quadrilaterals, four-sided shapes, that are inscribed in the circle. Figure STUV is a cyclic quadrilateral. And we have angle S marked as 114 degrees, and they want us to find angle U, which they marked with an X. The angles are opposite from each other, so I can use that justification. Opposite angles of a cyclic quadrilateral are supplementary, meaning the measure of angle S plus the measure of angle U added to be 180. Justification, opposite angles of a cyclic quadrilateral are supplementary. If I then substitute the 114 plus X equals 180, subtract the 114 from both sides, and I get X is 66 degrees. Now take a look at the next problem. Try to solve it, pause the video, and when you're ready, resume it to check your answer. I'll give you a minute. Alright, hopefully you had time to try this problem on your own. In this case, we're told that the measure of angle V is 2x plus 60, and the measure of angle T is 4x. Those angles are opposite from each other, and this is a cyclic quadrilateral, meaning the measure of angle V plus the measure of angle T add to be 180, because the opposite angles of a cyclic quadrilateral are supplementary. Substituting 2x plus 60 plus 4x equals 180, if we combine like terms on the left-hand side, we get 2x plus 4x, which is 6x. So we get 6x plus 60 equals 180. Subtract the 60, divide by 6, and we find that x is 20 degrees. Alright, thank you for watching, and I hope this helped you.